Hello, my name is Mike Zaida, and I'm giving a keynote talk today entitled The Metaverse University. And I'm going to bring up my slides. Here they are. So mostly you're going to see my talk slides. I think I'll put my little, I see. I've got to do play. Do that. Then put the little picture of me up in the corner. And so you'll see just a little picture of me and you'll see slides. All right. The Metaverse University. This is a conference on digital media, art, and technology held at the Beijing Film Academy in 2022. So a little bit about me. I am a ACM fellow. I'm an IEEE fellow. I'm a USC professor of engineering practice. I'm an advisor to 11 plus startups globally. I've been an expert witness on 36 law firms, 49 cases, a patent litigation for 58 game and computing companies. It's quite a bit. My website is mikezida.com if you want some more information about me. In 2005, I founded the games program at USC, called the USC Game Pipe Laboratory at the time. And the purpose of that program was to provide a stream of engineers and artists and gameplay designers to the rapidly growing games industry. In 2005, since 2005, the games industry has grown by a factor of 5 in size. And the program I created at USC has graduated some 4,000 plus students into positions in the game and computing industries. And we are now in a rapidly changing environment where major efforts are being placed on creating the metaverse. Technologies are quickly being created to support the metaverse and its application. The metaverse that is being created is starting from games, but it's not limited to games. There are applications in medical, engineering, and others that are also demanding a place in the metaverse. There's not much university focus on the metaverse, and there are scant educational programs to support this growing field. And without an educational program focused on metaverse technologies and their application, this new field will not be able to grow. We proposed the creation of a new educational entity called the Metaverse University, an educational institute that will graduate engineers, artists, designers, and producers that can design and build our future metaverse technologies and applications. We plan on creating a university without departmental boundaries to eliminate the stovepiping issues we discovered in the stand-up of the various games programs. Our model will be similar to that of Rockefeller University, where all faculty and students are just members of the university, not departments. Students will follow educational tracks. There's going to be a metaverse design track, a metaverse development, a metaverse art, and audio and production tracks. And the last year of each student will be a year-long team-based metaverse development project capstone course, followed by a demo day for a presentation of the developed technologies and applications. So this is kind of what the Metaverse University looks like. And what you'll see is there's a metaverse development on the left side. That's like the engineering, the computer science side of metaverse development. There's metaverse design, which is how do you go and design the metaverse? It's all in 3D. It all has to be networked, and designers need to know how to do that. There's a metaverse art and design track, and there are multiple parts of metaverse art and design. One is concept art track, another is 3D modeling track. There's a metaverse animation and VFX track, and there's a metaverse sound design track. So those are the different degrees that will come out of this new university, the Metaverse University. And all of the students will end up together in Advanced Metaverse Projects 1 and 2, which is our year-long Advanced Metaverse Projects class that allows the students to pitch ideas that inform teams and spend basically 2 academic semesters building a metaverse project of their dream. And the best projects will go to an incubation and acceleration center for metaverse and technology startups. And all of our students are going to go through a class on startup pitches, productization, business models, and IP development. So what does the educational program look like? We'll go through the 3 of the parts, the development, the design, and the art and design. And metaverse development is the engineering part of building the applications that allow users to move through and interact with the developed 3D graphics world. And until recently, building a 3D environment for a metaverse required strong, relatively low-level game engine programming. The programmer would decide to use the Epic, Unreal, or Unity engine, and typically would find that the engine required significant software development before it could be properly used. Engines are typically not yet ready for much non-programmer development. You can kind of go up onto the Unity web store and download a 2D side-scroller game starter kit, and you can change a few things, but once you get doing complicated things like AI or networking, you can't be a non-programmer and deal with that. So the metaverse industry has created a number of platforms that are built on top of these engines. And platforms are typically built on top of a game or similar engine. And the purpose of having a platform is to reduce the complexity of metaverse application development. And some of the platforms available include NVIDIA's Omniverse, Unity's Metaverse Toolkit, Intel's Metaverse Toolkit, Microsoft's Metaverse Toolkit, and Epic's Fortnite Creator and Roblox. Now, to be able to graduate strong metaverse developers who put the following courses into the Metaverse Development Degree Program. We have Metaverse Design Workshop. Every single person who goes through any of our degree program tracks in the Metaverse University will take this design workshop class. There's a 3D computer graphics and rendering course. There's the Metaverse Platforms and Tools course. There's a Metaverse Modeling and Simulation course, a Metaverse Networking Infrastructures course, a Machine Learning for the Metaverse course, and a Building the Human Intelligent Metaverse course. So you can see it's quite a complex degree program and strong technically. So the Metaverse Design Workshop class is taken by all students in all degree tracks at the Metaverse University. The purpose of the class is to teach our students how to think in 3D for metaverse development and how to generate an appropriate metaverse design document, an MDD, before cutting code. You want to have that design document done before cutting code so that you can kind of scheme out what has to be built. And this class has the students develop a runnable prototype using one of the available industry platforms once their MDD has been completed and approved. And the MDD is not unlike the game design document used in the games industry, except that designing an application that will be in 3D with a 3D interface and has all of its digital art in 3D is somewhat more difficult than the 2D side scroller typically found in games programs. Some water. In the Metaverse Development Program, we have to make a decision as to what appropriate foundational courses should be required. And one such course is a solid course entitled 3D Computer Graphics and Rendering. And most university computer science departments have this course in some fashion. And universities that are hopelessly out of date will have the students in this course turn lines and triangles into pixels in an in-memory frame buffer. And this is out of date, as this is all done in graphics hardware today. This kind of course might have been appropriate, say, in 1979 version of this course, but it's not appropriate today or for the Metaverse University. For the Metaverse development realm, there is probably high-level viewing and matrix transformation functionality, so students that will be building at that level should understand such mathematics at the symbolic level as presented in the textbook by John Hughes and Jim Foley and Andy Van Dam and Steve Feiner. Additionally, students that come out of this course should thoroughly understand shaders and rendering pipelines as are provided by today's graphics hardware. Here's the Metaverse Platforms and Tools course, and we start out with the Open Metaverse standards, because if we get standards in place and use them, then building things becomes simpler. There's things like Pixar's Universal Scene Description language that's used in NVIDIA's Omniverse. There's the NVIDIA Material Definition language. There's Material X, which is an open standard for materials and their visual display. And there's the BIM, the Building Information Modeling, Physical and Functional Characteristics. So we start out our students learning those open metaverse standards. We then make them look at game engines, Epic Games, Unreal Engine, and the Unity game engine. And then just so that they know what's different between an engine and a metaverse platform. We then have them look at NVIDIA Omniverse, the Unity Metaverse Toolkit, Intel and Microsoft's Metaverse Toolkits, and Epic's Fortnite Creator and Roblox. The Metaverse Platforms and Tools course starts out again, as I said, with Open Metaverse Standard tool sets. And I think I've said all of this on the previous slide, so I'm just going to skip ahead. NVIDIA's Omniverse is an outstanding choice for the student interested in creating a metaverse that requires high performance graphics processing units, as are manufactured by NVIDIA, of course. If the student is interested in a platform that works on pretty much any hardware, then the Microsoft Intel Unity Metaverse Toolkits are the way to go. And add an even higher level functionality that is less complex programmatically, the Epic Fortnite Creator and Roblox platforms are what to utilize. So the purpose of this class for the student is how to utilize a modern metaverse platform, as well as how to use a game engine that may be under that platform, as the engineer may have to add code at the engine level for a special feature not in the higher level platform. There's a metaverse modeling and simulation course. We started with time management and real-time simulation. When you build a metaverse, when you build a 3D game, you have to figure out, how do I manage time? Because I'm going to create an event that happens on machine number one, and machine number two gets that across the network somewhat later. And how do we deal with the time disparity between the origin of the event at one machine and its delivery to other machines in the network? We cover a classic paper by Leslie Lamport called Time Clocks and Ordering of Events, talk about discrete event simulation at the start of this metaverse modeling and simulation course. We then go and look at physics engines. In NVIDIA Omniverse has NVIDIA PhysX, has things called blast and flow. We make sure that you learn about real-time collision detection, because almost everything you need to do in a 3D metaverse world is test something, what's its name, what's its color, what does it do, what should we do to this thing we just touched, and keep your characters as they walk through the world on the ground. You've got to have a real-time collision detection capability. And the final part of this class is deal with the issue of digital twins. And digital twins are real-time virtual representations of a real-world physical system or process. And the idea being, you've got this model running on a very high compute capable set of processors, and it's modeling something that's happening in the real world at the same time, which means that there's going to have to be some kind of sensor fusion, taking in sensors from the real world that tell you what changes are going on in the real world, so you can change the digital computational twin. You've got to have system simulation, you've got to have integration, testing, monitoring, maintenance, all of those things to make digital twins happen. All right, so I've walked over this. Next course is Metaverse Networking Infrastructures. And networking is interesting because a lot of people look at networking of games and say, well, the Unreal Engine comes with a networking kit and capability, and the Unity engine comes with a multiplayer infrastructure as well. Why should we actually take a class in this? And the reason you take a class in this is so that even if you use somebody else's networking engine, you've got to understand the issues. So in this class, we talk about performant network infrastructure challenges, which are what are the hard things that you have to think about when you network in the metaverse, players who are on other machines that also might be in other metaverses. You have to talk about latency, reliability, bandwidth, and protocols, because latency is everywhere, and most of your job as a networking engineer in the metaverse will be, how do I beat latency out of the system? We've got to talk about communications architectures, because there are things that you can make great progress fast that aren't scalable and don't work over the long time. And so we try and let you look at all of those so that you can make your choices properly. Managing shared state. If you think about machines that are all in the same metaverse, or that are all in several metaverses that are talking together, we have to figure out how to do that. Designing for latency reduction, again. Scale building performance, as you want to grow from, a couple of thousand players to 1 million players, what do you have to do? And we'll talk about commercial architectures for scalability. There's some wonderful game companies that have built absolutely wonderful architectures that we should look at. Complex infrastructures, again, the open metaverse. How do you architect the metaverse for interoperability? And modeling communication in the metaverse and securing the online metaverse. So all of these are very important in the metaverse networking infrastructure course. So I'm going to skip ahead. Now, networking doesn't just come with a game engine. I mean, the game engines have networking, but it's really simple. And so this course is really important. It's critical. And the issues are well discussed in IEEE Computer, March 2022. It's a paper I wrote there, pages 128 through 29. And the interested reader is pointed towards that article. Now, figure 4 shows what a traditional client-server game architecture looks like. And a lot of metaverses are starting from this traditional client-server architecture. And I'm just going to show you the picture and have you look at it yourself and not go over it in great detail. The next figure shows what we really need to do if we want a virtual space to accommodate, say, the number of players that attended Woodstock, for example, some 400,000 spectators and players that can walk from one end of the farm in Bethel to the other without having to transit a game lobby. And that's how it will go if we create a single metaverse properly and not just make it a marketing term for games that allow character mods. So this is an illustration of scalability in a single metaverse organized by virtual space. So the idea here is P of I is a persona. I'll describe that in figure 6, which is coming up. And SM of I is a server maintaining a part of the virtual space of this particular metaverse. So you'll see that we have some personas in the lower left that are connected to SM of I, which means those personas, those avatars, and information that goes with those avatars can walk around in the particular virtual space of this metaverse until they get to the end, but then they have the ability to transit, say, to S2 of I as they move on, and their persona can be detached from SM of I, moved over there, or they can see the continuation of the world. So the idea is if we start it with a map of the world, and assuming we put this 2D grid all over the entire globe, and of course taking care of all of the curvature of the Earth, then we'll have this very interesting capability to be a scalable single metaverse. This is kind of like what Second Life did, by the way. I'm going to move between different metaverses. I call that metaverse I. And we need something like figure 6. In figure 6, we see open worlds and AOL-like walled gardens. And let's just go to the figure. So AOL-like walled gardens is I'm in metaverse I, and you'll notice that it has a solid black thick box around it, which means once you're in metaverse I, you can't leave to go to another metaverse. All right, same with metaverse J, and we call that a walled garden or an AOL-like walled garden. If we have open worlds, which is I'm in metaverse K, then we have a dash line around it, which means we can take our persona and walk from metaverse K into metaverse N and participate in metaverse N. Now, the idea of a persona is it's your 3D avatar, it's your friends list, and whatever data that needs to come along with it. So if you've gotten particular scores in metaverse K and things from metaverse K, they come with you in some digital form. Maybe metaverse N can't use them, but they stay with you because you might walk back to metaverse K, where those things that you have will then once again be active. Friends list, this is sort of my bugaboo of everything. As you know, when you're in Facebook, you can't move your friends list to any other social media platform. And I think in the future, that's going to be something like the European Union is going to require it. And then it will become something we have to go back and architect in all the systems where we didn't put it in the first place. All right, machine learning for the Metaverse course is conducted at the application level as opposed to the mathematical fundamentals of machine learning. Basically assumes that you've taken a machine learning class. And the application of machine learning to Metaverse development is an important focus. This course covers the use of machine learning for AI bot creation, metaverse interaction and analysis, and real-time metaverse user understanding. The idea being that you've got all of this interesting power of machine learning that you deploy inside of the metaverse. And we have a course that lets you explore and work in that. As metaverse platforms move beyond their game engine origins, embedded machine learning for operation, analysis, and understanding of metaverse interaction will become a prominent and important component of metaverse platforms. It's going to be there. You're not going to have to tack it on the side like most things right now. One of the final classes building of the development side is building the human intelligent metaverse. And that course provides an understanding of the available biosignals generated by humans, sensors that can read those biosignals, and human modalities that can be computed from biosignals. And the topics covered include human-generated biosignals, emotion states, emotion sensors, and computational models for interpretation, emotional state vectors, detected emotions and probabilities, sensor bandwidth, power, and computational requirements, physical state sensors and their computational models, mental state sensors and their computational models, sensor fusion, machine learning for computing human states and modalities from sensed biosignals, and computed human modalities. Again, this references an IEEE paper I put in IEEE Computer, September 2022. So this is a mind map of what that course looks like. So you'll see human-generated biosignals, you'll see biosensors, there's a speech and motion recognition, there's eye tracking, there's body tracking, there's hybrid EEG, there's facial expression analysis. All of those are biosensors, and they feed into behavior model deployment, where we have sensed world architectures, where our sensors sense what's happening in the world. We have human models where we've figured out what's the emotion state of this human, its physical state and its mental state, such that we can then interact with AI character models where there are virtual emotion states, virtual physical states, and virtual mental states in those AI characters. It's a very important point. It's not in the picture. Interactive experiences in computational human perception is basically where you go and build interactive experiences, potential commercial products, and R&D projects from in and around the space of the human intelligent metaverse. Metaverse design is degree program is where it teaches creatives how to draft a metaverse design document, a document that's written before code is developed, describing how the metaverse app goes together, how its user interface works, and any other important design features. And the courses taken by students in the Metaverse Design course are the following: Metaverse Design Workshop, Metaverse Visual and Interface Design, Metaverse Platforms and Tools, Metaverse Sound Design, and Metaverse Development 1 and 2. We already defined the Metaverse Design Workshop class above, and we're not going to repeat that. Remember, every track in the Metaverse University takes this design workshop class. The Metaverse Visual and Interface Design course is one of the most important. In this course, design students are taught how to think conceptually in 3D, such that a coherent, unified 3D interface for the Metaverse app can be specified. The course also teaches how to think software architecturally, such that the overall 3D user interface defined is used in the same way for all parts of the specified app, and in fact, for all apps of the series expected to be developed. That's a very important point. And the Metaverse Platforms and Tools course we discussed above, we wouldn't do it again. Metaverse Sound Design course is a tool and software level course that teaches the designer how to create sounds and utilize them in a metaverse platform such that we see a sound and hear a sound, as sound designers are wont to say. And this course additionally covers music integration into the metaverse platform. And again, sound integration into a 3D metaverse means that it is the metaverse user's expectation that sounds will be appropriate to their spatial location and to the characteristics of the 3D virtual materials in that part of the metaverse. The Metaverse Development 1 and 2 courses are courses where the students form small teams for the creation over the course of a semester of a prototype metaverse implementation selected by each student team. And the idea is to get the students used to building rapid prototypes of metaverse apps with high-level platforms. These two courses must be completed before the students move into advanced metaverse projects course. Metaverse Art and Design degree program focuses on the creation of art and sound assets for the use in the development of metaverse apps. There are 4 tracks in the Metaverse Art and Design program: concept art, 3D modeling, metaverse animation and visual effects, and metaverse sound design. The concept art track focuses on teaching the student how to make concept art that properly communicates to the developers of the metaverse application what that particular metaverse should in the end look like. It's always nice to know expectations before software and 3D assets are cut. In the concept art track, student takes the following courses: Metaverse Design Workshop, the basics of concept art, styles and anatomy, character design, metaverse world design, and pose and lighting concept. And basics of concept art is exactly that. That course teaches the student how to create concept art that visually displays the vision as expressed in writing by the metaverse designer. And the styles and anatomy course teaches the student how to create a coherent style for the concept art, as well as an appropriate anatomy of human and other figures to be shown in the concept art. And character design is the course for building the concept art of prominent characters in the metaverse. Metaverse world design is the course that teaches how to create 3D worlds where your metaverse app takes place. And a concept art student in that course will focus on concept for such 3D worlds. Pose and lighting concept is the course that teaches the artist how to pose and light characters and the world model. The 3D modeling track focuses on teaching students how to build all of the 3D parts of the metaverse app to be developed. The courses in that track are Metaverse Design Workshop, Basics of 3D Modeling and Digital Sculpting, Metaverse World Design, Character Modeling, and Model Production. Basics of 3D Modeling and Digital Sculpting course is exactly what that course's title is. Metaverse World Design, we detailed above. Character Modeling is how the 3D characters are designed and built for our metaverse. Model Production is a course on how to create a pipeline process for 3D art production for a metaverse development project. The Metaverse Animation and Visual Effects track is how we give life to the characters and the world we have developed for our metaverse. Courses in that track are Metaverse Design Workshop, Basics of 3D Animation, Character Animation, VFX for the metaverse, Anatomy, Study and Rigging, and Structural Production. Basics of 3D Animation teaches the student classical animation methods for getting the characters in the world in motion. Character Animation is how we bring our characters to life and provide their visage with emotion. VFX for the metaverse is how we use special effects to animate the world, make it have a particular ambient emotion. Anatomy, Study, and Rigging is how we create a framework inside of our 3D characters that we can manipulate by way of our available user interface. And Structural Production is how we create a pipeline of 3D modeling, animation, and VFX for all of the characters and worlds and all of the artists working on our production. This is very important. Metaverse Sound Design track is how we create artists that can develop and integrate sound into our metaverse productions. The courses in that track are the following: Metaverse Design Workshop, Basics of Sound Creation, Metaverse Sound Design, Metaverse Platforms and Tools, Music Creation, Production and Licensing, and Spatial Sound like Dolby, THQ, and other technologies. And the course titles are accurate as to our expectation as to what will be covered, and building sound and music for use in the metaverse is critical for creating the illusion of life in that world. Advanced Metaverse projects. All of the students in our program take Advanced Metaverse 1 and 2 courses. And these courses are team-based production of a significant metaverse application or technology over the course of 2 semesters. The spring semester before this year-long project is where the students pitch their proposed plan as to what they would like to build over the course of a year, and university faculty and staff watch those pitches and develop a green light list as to what is approved for production. And one of our final courses all of our students must take covers how to create a successful startup pitch, how to productize, develop prototypes, business models for marketing your prototype, and intellectual property development and protection. And we plan on teaching our students how to fish out of our degree program, which means help them get a job or help them create a company or a startup. Incubation and Acceleration Center, the best projects from our students in the Advanced Metaverse Projects course have the potential to be accepted into the Incubation and Acceleration Center. And in that center, we provide space and resources for student teams to advance or complete their metaverse application. We additionally provide them guidance toward potential investment partners. Okay, the end. Web3D and the NFT is whenever I mention to people that I'm planning the creation of a new university, the Metaverse University, I either get great understanding from real tech people who have been in the 3D virtual environment space for some time, or I get the blockchain, Web3, NFT fanboys, fangirls telling me that the metaverse is just about Web3 and how they will soon become rich beyond their wildest dreams, and asking me what I think about crypto. So I usually delete any person who chats with me on crypto online, but I do believe we should perhaps study the whole blockchain, Web3, NFT space to see if there is some nugget that is not fully and foolishly useless. support. All of the above is a proposal to build Metaverse University. We have developed the course plan for the educational program and have had initial discussions with potential faculty. We have developed an operating budget for the first 3 years, and we are looking at various sites for the startup of the Metaverse University, Los Angeles, Seoul, Dubai, and are looking at acquiring the first space, a space that could educate students in Los Angeles. We're looking for a key sponsor partner for the first 3 years of operation for the Metaverse University. We believe that by the start of the 4th year of operation, that tuition fees will be able to cover this university's operating costs. All right. So this is my contact information, and I will leave that up there just for a second or two so people can copy that. And I want to thank you for this invite to be a keynote speaker to your conference, and I hope the rest of your conference is absolutely wonderful and great. So thank you very much. Stop sharing. And I wish you all a happy and great rest of your conference, and have a great day. I'm Mike Zaida.